Hello, we have finished with the lines and now we are going to start with planes, right? So in 3D, we have three different equations of plane, and in that sense, we have a limited number of equations for planes, only three. So if you can tackle these three with its concepts and deductions, then I am sure that the problems related to planes will be very easy for you and you will be able to score, right? So because of that, I am going to now deduce all the equations with reference to the visual aids, and on the top of that, let me try to tell you that even if I show you the deductions, I will not show you the complete steps, that means the statements. I'll only show you the mathematical statements so that it will take less time, right? So without delay, let us start the planes, right? So we are going to start with plane. So first of all, there, as I told you, there are only three types. The first one, type 1, I mention it as type 1. Type 1 is the normal form, right? We call it normal form, and we even call it standard form because whenever we need to take a reference, then we take this as the standard form of the equation of plane. Now depend on the requirement, we will be finding the equations. What is the requirement? Just you see, this contains, right, equation of plane whose perpendicular distance from origin is known and unit vector along this perpendicular is known. So these are the two things which you must know in order to decide what is the equation of this particular plane. What are the two? Perpendicular distance from the origin and the unit vector along this perpendicular, right? So before I go for the deduction, let us just see the three-dimensional model of this, so that if I draw it here, it will be very easy for you to comprehend, right? So let us take that model and then we'll directly transfer this to the board, right? Okay. So let us consider this. Supposing that this is the plane whose equation I need. This is the plane whose equation I need. And then I need to know also what? Perpendicular distance from the origin. Right? I am holding it like this in a inclined position so that you can see it. Suppose this tip is the origin. And from here, this is the perpendicular I have drawn here. You can see this is the perpendicular, right? And this is the origin. So this distance is known to us. That is, suppose this is D, right? And the unit vector along this be n cap, right? Just try to visualize this. N cap is the unit vector. This is the origin O, and I have drawn the perpendicular. The foot be n. Now I have to find the equation of this plane. So to find the equation of a plane or any curve, you need a variable point. So what I do, one variable point I have fixed in the plane. Anywhere I can fix this point. This is a green point, right? So now I have to get a relation of this with this particular variable point. That's the equation, right? So how do we do it? Just you see, I have a perpendicular to the plane. I have a point here. This is a foot of the perpendicular. Now if you join this point with the foot, right? So can you see that line segment? This part is the line segment joining this point. That is a variable point. It can be anywhere with the foot. So now it is entirely lying in the plane, right? You can see, and this line is already perpendicular to the plane. So in particular this line is perpendicular to this. So if you want to get the mathematical expression, what you can say, the dot product of this vector and this vector will be 0, and once you get this, your equation will be ready, right? Now we'll transcribe this into the board. Now it will be easy for you to comprehend, right? Bring this figure, keep it here fresh, and then see the figure in the two-dimensional board, right? Okay, so now let's, without delay, we do that. Okay, so this was the plane we had, this was the perpendicular, it was the origin, it was N, right? And I have considered a point, say this is P, which was the green that pin. Then I have joined this, right? So obviously this angle is 90 degree, already I have shown you, right? So now this vector is N cap, and the distance I consider is D. Clear? So now for deduction, what I'll do, first of all, if I ask you to find what is ON, ON is a vector whose length will be D and the direction is given by N cap. So this vector is D N cap. There is no doubt about that. Then I am asking you to find what is vector Pn. So Pn means position vector of N minus position vector of P. Position vector of P is a variable point, so we will consider this as R. So it will be what? Position vector of N. Position vector of N means this one, Dn cap, and position vector of P means R vector. Now, as I told you, these two lines are perpendicular. So what you can say? Pn perpendicular to On. This implies dot product of these two is going to be 0. If dot product is 0, you put this particular values, I cannot say expressions, and then try to simplify this into this, d square, and then n cap dot n cap will be what? 1, and then r dot, d is a scalar, so I'll write here without disobeying, means following the rules. So ultimately one d will be cut and you will be left out with r dot n cap equal to d, r dot n cap equal to d. So this is what is the required equation of this plane. Be very alert. Before I move on to the next part, let me again re-emphasize, n cap is the unit vector perpendicular to the plane. Not necessary that it should be drawn from the origin, because if I have this particular perpendicular from the origin and other from some other points, they will have the same unit vector. What is the reason? Because both this will be parallel. So your perpendiculars can be anywhere, right? So this unit vector can be anywhere, just it needs to be perpendicular to the plane, right? And d is the perpendicular distance from the origin. This has to be from the origin. This is very important, right? So this is the equation of the plane. Now let's go for one step ahead of modifying this. Let's see what can be the other expression of this particular equation, right? Because we need this. So this I mark as star because we have to convert this into Cartesian form as well. Now you look at this and just try to remember, how did you represent one unit vector? It is vector divided by its magnitude, and then we can have it like this. This is a real number, can be multiplied that side. So if you multiply and you bring it to the simplified form, then you are going to get another form. Yeah, for a moment you can define or you can denote this by d dash or whatsoever, any other letter you can use, because this is going to be a scalar, a real number, right? So now this is the another form of the same equation. What is the basic difference? That is very important to note. Make sure that this difference you comprehend very well, so that there will be no doubt left on this particular topic. Did you get it clear? In this case already I discussed. Here I modified, n cap has been replaced, and once we did the expression of n cap replaced by n vector divided by its magnitude and simplified, then we got r dot n vector, remember it, is equal to d times magnitude of vector n. Try to understand. If you have a general vector, a normal vector, not unit vector, right, with this variable points, then the right hand side is not the perpendicular distance. In fact, it is perpendicular distance times the magnitude of this vector. Did you get me? So whenever you find the equation of a plane in such a way that the component or the vector multiplied to this r is not a unit vector, right hand side is not representing the perpendicular distance. So do not do a foolishness of directly writing the right hand side as the perpendicular distance without verifying whether this is a unit vector or not. Only in case of unit vector, this will directly represent the perpendicular distance of the plane from the origin, which is shown here. Did you get it? Again, if suppose you get this form, how to obtain the perpendicular distance? Very simple. You can see the right hand side, it's multiplied by what? Magnitude of the vector which is with r. So once you get this form, the right hand side quantity should be divided by the magnitude of this particular vector, and then you will see whatever you get is the required perpendicular distance. Did you get it? So now let me go for its Cartesian expressions, because both are well linked and it's needed actually, it's very important, right? You must be very clear about that. So first of all, I'm going to convert this. So I just want to rub these things. But let me just try to tell you again that once I try to convert this into Cartesian, the variable points always is considered as x, y, z, right? There's no doubt about that. And then now one important point to be understood. If I'm talking about a unit vector and I try to express this with the help of its components, remember its components are the direction cosines of the particular line along which this is a unit vector. Means if I try to write n cap, I have to write n cap as this, where L, M, N are the direction cosines. This is of this line, right? In that case, if I try to now simplify this, how will it look like? You just see R components are this. So if you try to write this in the complete vector expression, it will be like this. Dot product, already I have given you this, and right hand side is d, there is nothing to be done, and then this will ultimately lend you to this particular equation, Lx plus my plus nz equal to t. That's what the equation of the plane in this particular requirements, normal form, right? L, M, N are necessarily the direction cosine of the perpendicular to the plane. Then this is a form, and right hand side quantity necessarily gives you the perpendicular distance of the plane from the origin. So this has been derived from that. Now you come to this point. Now if you consider any general vector which is not a unit vector, the components are necessarily direction ratios, right? So once it is a direction ratio, what should be the symbol to be used? For our convenience, I am telling you, small a, small b, small c. So this time components of this will be small a, small b, small c. In the similar way, if I write, the equation will reduce to ax plus by plus cz equal to d times something. I'll write as this, right? So this is what the another form of the equation. I could have shown you here also, then it would have been little more clear. Instead of writing d dash, you could have written d times magnitude of n, that is root over a square plus b square plus c square. and that's the quantity by which you have to divide d dash in order to obtain the perpendicular distance. So please make sure 2 points, right, for both the equations. Whatever are the components of the variable x, y and z in these two forms, they are going to represent either direction cosines of the line perpendicular to the plane or a set of direction ratios of a line perpendicular to it. Second point, plane does not have its own direction cosines or direction ratios. It has only the direction ratios or direction cosine of its perpendicular, because if you draw anywhere any perpendiculars, every time it has the same direction cosine or proportional direction ratios which will be uniform throughout. That's the point. So this is the first form. I'll be taking up the problems. Let me first explain the second form, right? I'll be taking all the problems together. I think that will be more logical. So now I'm going for the second type of the plane, right? Second type, type 2. Type 2. What is the type 2 requirement, right? So it is equation of plane which is passing through a given point and perpendicular to a given line, right? Given line or given vector. So this time also there are two requirements. One point through which the plane should pass. Second, we should have a perpendicular to the plane, not necessarily from the origin, right? Now let us see the model first, then we will proceed further. This is the plane whose equation I need, and it is given that this is the point, this is the vector to which it is perpendicular. This angle is 90 degree, this angle is 90 degree. ठीक है, ये मैंने सुविधा के लिए, for the convenience I have fixed it here. You can keep it floating somewhere here. Only condition is that it should be perpendicular to the plane. Next, I should have a point, right? I should have a point. Suppose this be the point, right? This be the point. Which point? Given point A. I want to denote it by this yellow point, right? This is the point, given one, right? This is the given point. Now, as you know, to deduce the equation, you need a variable point. So, in the whole plane, anywhere, this point is a variable point, anywhere you can consider. I have fixed it here, right? This is the variable point. Once I get the variable point, suppose this be P, this be A, I joined AP. So, this is the line segment which is entirely lying in the plane. This is already perpendicular to the plane. So how would you like to relate these two? It's a common sense. If this is perpendicular to the plane, this has to be necessarily perpendicular to each and every line lying on the plane. In particular, this will be perpendicular to this. So dot product of this vector and this vector will be 0. That's the working rule, right? With the help of that, we are going to deduce the equation of this particular form. Let's see. Now if I draw the figure, you will not face really any problem in understanding this. This is very sure. So this is the plane. It was passing through the point A, whose position vector I marked as A. This is the vector. We are writing capital N for emphasizing it. This is perpendicular to the plane, right? And anywhere in the plane I consider a point, variable point P. Suppose this be the point P, which I write like R with position vector R. Then I was asking you to join AP. So AP will be without any problem perpendicular to n. So their dot product will be 0. So directly you can write what is AP. AP will be R minus A, and n is already known. So what can you say about the dot product of AP and n? It is 0. So R minus A dot n is equal to 0. So that's what is the required vector equation. R minus A dot n is the required vector equation of the plane where A is the given point, n is the given vector perpendicular to it. Right? Now it's very easy to convert this into Cartesian form because earlier already we have got the experience. So see, this is a vector, so it definitely have some components. Let me write the components as A I cap. Okay, for emphasizing again we are writing the component also as capital. This is not at all necessary to write it like this. Next, this is a point which is known point, so we'll write it as x1, y1, z1. It is a variable point, we'll write this as xyz. Right? So now make your common sense ready. Dot product, if we do component wise, you have to multiply. First thing. Second thing, if I ask you to find r minus a, component wise you have to subtract. So what is r minus a components for I cap? R minus a, that is this minus this. It is x minus x1 is the component. Dot product is taken with whom? This vector. So component wise if I multiply, it will be multiplied to whom? A. So A you write here. Right? Even if this vector is written afterwards, right, I am writing A here. There is a reason. Normally the scalars are to be written before the variables, right? The next will be giving you what? Y minus y1, C, z minus z1 equal to 0. So this is what the equation is. I do hope that you have understood the deduction. I did not show you finding all this. You can do it now because you are good at vector now at this moment. Right? So if you find difficulty in remembering this, you can go for the alternative forms. Right? Keep all the variables in the left side and the constants in the right side. So you'll immediately find your equation will be looking like this. Right? Your equation will be looking like this. So this one also you can remember in order to make sure that you do not forget it when it is in need. Next, the concluding point I would again like to emphasize, because every plane has this particular feature. Whenever I express this equation of the plane with this requirements that there is a vector known and a point through which it is passing, then I arrived at this equation. Now mind it, the coefficient of the variables a, b, c are the components of that vector which is perpendicular to the plane. Rather, I would say these are the direction ratios of the plane, of the vector perpendicular to the plane. So always remember, whenever you get any equation of the plane, coefficients of the three variables represents the direction ratios of a line perpendicular to the plane. Make sure again, please try to just compare with the first form as well. This is the feature which is being carried by its plane, and this is a strong point. Remember it, this is seems to be a very small point, but this is a very strong point which is going to help you to clear the doubts, clear the problems of this. Right? Okay. So now let's start with the third one. First, let me finish with the deductions. Right? Actually, the first one, once you understand, the second and third are not at all difficult, right? So third has a very small requirement, type 3, passing through 3 point, right? Plane, equation of plane passing through 3 points, right? For a moment I would say that 3 non-collinear points, because if the points will be collinear, what will happen, that I'll explain, no problem, but non-collinear points, right? So first again as I already have practiced. I'll show you a three-dimensional figure, then we'll move on to the deduction, right? So let's have that look and then we'll see. Just see this. Suppose this is the equation of the plane. This is the plane whose equation I need. I have 3 points. I mark this time these points. This is A, this is B, this is C. And already I told you that for finding the equation you need a variable point. I consider this point P, right? I am bringing it very close to you. Give a look at this. What I did, A point has been joined to this point B, C and P. Choice is yours. You can even join B to this. No restriction at all that you have to join like this only, right? You can join this here and then you can join this and then you can join this. No problem at all. You will be getting the same equation every time. But to keep the outlook or the look of the equation same as in the book, I did join A to B, A to C and A to P. Now what is the working rule? Try to understand. Okay, looking at the plane, you can easily see that all these 4 points are lying in the plane. Now in any way, if you join any two of the points, these are going to be the lines lying on the plane. That means all the 3 line segments which I have drawn are lying on the plane. But now there is a problem. Earlier 2 deduction shows that I need to know a perpendicular to the plane. Then only I am successful in finding the equations, right? Where from I'll get it? Now see what we do. For that, we'll take the cross product of these 2 vectors. Now remember the geometrical interpretation. Cross product gives you what? A line perpendicular to the plane containing these 2 vectors. A vector perpendicular to the plane containing these 2 vectors. So this is the perpendicular. This is this AB cross AC. Now just you tell, is this line perpendicular to AP also? Is this vector perpendicular to AP also? Exactly. So what can you say about dot product of this and this? This is AB cross AC and this is AP. The dot product will be 0 and that's it. That's the equation, right? So we'll be getting it done here in the board. So for deduction, so we'll draw the figure now. What it did, right? So this is the plane whose equation is needed, and we had 3 points. This is A, position vector is A, capital B, position vector is B, capital C, position vector is C, and one variable point. Anywhere you can consider. I consider it here P. Then what I did in that particular model I am showing you, I joined this vector AB, this vector AC and this vector AP. I would like to tell you again, you do not have any restrictions in joining this. This is not that you have to always join in this way. Only you have to create 3 line segments, rather I said 3 directed line segments, that is vectors in the plane. Any manner, right? Only take care that you will not involve R more number of times, because moment the unknown quantity is involved more number of times, your complications will be started when you try to resolve it in terms of simplifications, right? So because of that, avoiding this R for more than once, you consider any 3 line segments, any 3 directed line segments and do the deductions, right? So here very clearly you see what I can say about AB, it is B minus A. What I can say about AC, it is C minus A. What can I say about AP? It is R minus A, right? And all these 3 segments are lying in the same plane, what I have shown you. And then moment I find AB cross AC, this becomes perpendicular to the plane, right? I'm not writing more number of words, just I'm showing you. If this is perpendicular to the plane, in particular this is this particular cross product is perpendicular to the line segment AP, directed line segment AP. What do you say about their dot product? 0, right? That's the definition, deduction. Dot product 0, right? AB cross AC equal to 0. So this is what the required equation, right? I did not replace these values. If you replace this value, it will be taking a very brilliant shape, a very symmetric shape here, which helps you to remember the equation in a comfortable way. I'll show you how to remember this equation so that you will never forget whenever it's tough time, right? Okay, how you will not forget it. Just remember that. First of all, you fix a point out of the 3, A, B, C, because when points are given to you, it is not necessary that they will give you A, B, C. So any point you can consider as A, any point B, any point C. Only coordinates will be there. So even if it is given, that's not an issue. You write R minus A, right? If you want to write R minus B, write that also. This is no problem at all. But whatever you write here, that two ordered pairs also should contains in that same place this particular vector only, you can see, and the other place you fill up by the remaining two vectors, that's all, and equal to 0. Only remember, dot product is outside and cross product is inside, and good logic is there. If you put a dot product inside, this whole thing becomes a scalar, and with scalar you cannot find a vector product. So this little common sense if you use, you can easily identify that this should be dot, this should be cross. I would like to write the another equation. Supposing that in exam, as I told you the idea, by chance you have written here B, what will happen? Nothing is going to be happen, right? You are going to get the same equation at last once you simplify. Here the loop will be different. Dot product. Then what have I told you? I simply told you that this will remain here only. This will remain here only, right? And what are the two others? A and C. Fill up here. A minus B and C minus B. That's it, right? And someone might write R minus C also. No problem, no issue. You can do it. Okay. So this is the vector equation. Now let's go to the Cartesian. Convert it. Okay, for Cartesian, what will happen this time? You have 3 points, x1, y1, z1, x2, y2, z2, x3, y3, z3. Right? I'll not mark the points over there. I'm directly deducing it. Just check the shortcut. You will never forget. I'm telling you. It is the Cartesian form, right? Cartesian form. Just try to remember, I told you earlier also that whenever there is a cross product and you would like to convert this into Cartesian, or rather I say in component form, then there will be an involvement of a determinant, 3 by 3 determinant. So there is a cross product. So there will be definitely a determinant. That's the idea how I strike. This is the determinant. Right hand side should be 0. Got it? At the beginning, forget about this part. These are the cross product. This is the cross product. If I ask you to write the cross product in the determinant form, where will be the component of this going? In the second row, because first row is occupied by ijk. Second row will contain the component of this. Third will be here. And as there is a dot product, ijk cap will be replaced by components of this, and that will be in the first. Done. So this is coming here in the first, right? Now replace. This is standing for general one, that is x. If I write for x coordinate, then it will be x1. Did you get me? So first one will be x minus x1, second will be y minus y1, z minus z1. Done. This will be coming in the second. Point B having coordinate x2, y2, z2. Point A, x1, y1, z1, right? Brilliant. So this will be what? x2 minus x1, x2 minus x1, y2 minus y1, and then z2 minus z1. Great. Third one will be what? x3 minus x1, y3 minus y1, z3 minus z1, and you are done. That's it, right? So I am telling you, I am 100% confident that you will never forget this deduction, right? You will never forget. Just listen once more if you are getting confused, and be very confident. These three forms you are never going to forget in your whole life, right? Okay, so now before going for any other theoretical parts, let's discuss some problems related to this. One more thing which I already told you while starting these deductions, that equation of plane passing through three non-collinear points. Can you remember that? But why did I say that this should be non-collinear? Yes, there is a question, right? I am bringing this with the help of this particular stick. Supposing there are 3 points which are collinear, one here, another here, right? They are collinear. Now just tell me how many planes you can draw. One like this, one like this, one maybe like this. There will be infinite number of planes passing through the points, right? So whenever the points will be collinear, there will be infinite number of planes passing through these points. Only single plane will not be there, right? And therefore, to break this particular point, we introduce non-collinear points while going for the deductions. But remember, while doing the questions, we will encounter this kind of problems where we will be told to find the equation of the plane passing through 3 points, and suddenly you will find that this equal to 0 means 0 equal to 0. We will not get any variable left here, right? 0 equal to 0, right? Always true equation. That's the point where we will have to comment like this, that these 3 points are collinear, and therefore there will be infinite number of planes through these 2 points. That's it. Let's start with the problem. Okay, I'll be giving some problems from the very basic level so that your concepts will be gradually growing up and build very strong, right? Let's start. Okay, first question. Find the perpendicular distance of the plane from the origin. Right? Whatever planes I am going to give below, you have to find the perpendicular distance from the origin. Say one equation of the plane I considered. Twice 6 plus 3y plus 4z equal to 5. Let me try to make one more thing clear, very clear. I think you already have noticed that I write these letters x, y, z like this. It seems like capital, but this is my habit that I write small x also by this particular pattern, right? So if I write a capital X, then even bigger I'll write for this, right? So these are all small letters, okay? So the way you like, you write, no problem. So this is the plane. Now I have to find the perpendicular distance from the origin. This is a very crucial thing. Many people in the sense students I am talking about, sir, ये तो बहुत ही आसान question है. Why 5 is the perpendicular distance? But do not be in the trap. Do not be in the trap. That's a trap. You try to compare first whether this form is that star or star dash. There are 2 forms in the deductions. Remember it. R dot n cap equal to d, r dot n vector equal to d times magnitude of n. That was verified by what? By the components of x, y, z. If it is L, M, N, right hand side is the perpendicular distance. If it is A, B, C, right hand side is perpendicular distance into some quantity, that is root over a square plus b square plus c square. So how will you verify whether these 3 numbers are direction ratios or direction cosines? Very simple. Find the square of them, add them up. If they will add up to 1, find direction cosines, otherwise not. So It's very clear here. 2 square is only 4. So their sum cannot be squares. Sum of their squares cannot be 1. That means they are not the direction cosines. So how will you manipulate it? Converting this into direction cosines. How did you convert direction ratio into cosine? If ABC are direction ratios, direction cosines are a by root over a square plus b square plus c square. Something plus or minus. So in the straight way, what we'll do, we'll divide it by this quantity. Right? We'll be dividing this by this particular quantity. And then moment we divide this by this quantity, we have converted these direction ratios into direction cosines. And the moment you get the direction cosines, the right hand side will become the perpendicular distance from the origin. Right? So that's it. You did the work. We have to write the calculation part. I am not writing yet. But I have to speak one more thing here. Right? Supposing that this quantity is minus 5. What you would have done? In that case, you take the negative square root. Right? You take the negative square root in order to make the right hand side positive. Because perpendicular distance will never be negative. So you choose appropriate square root sign in order to make the right hand side a positive quantity. So here already positive, so positive square root, and then this, if we work out how much it will be, 16 plus 9, 25 plus 4, 29, right? So I am not bothering about this, but of course I have to say something with reference to this also. This is star. So after that you have to follow a statement, remember it. So you write which is in the form Lx plus My plus Nz equal to D. So D equal to 5 by root over 29. Make sure you rationalize this and you write units also. This is the required perpendicular distance, right? Perpendicular distance from origin, right? That's it. Okay. Now you see this same question we can twist. Instead of asking the perpendicular distance, I could have asked you, tell me the direction cosines of the line perpendicular to this plane, right? Direction cosines of the line perpendicular to this plane. Now just try to see what are these elements. They are the direction cosines of what? The line perpendicular to the plane. If you remember, I re-emphasize many times, plane doesn't have its own direction cosines or direction ratios. It has its only perpendiculars. So if I ask you what are the direction ratios or direction cosines, better cosines, then you have to write this 2 by under root 29, 3 by under root 29, 4 by under root 29. That's all, right? So this is one of the very important equation. See, I am taking more time because this is very, very sensitive, right? Many students commit a mistake, and if you are not able to grab this concept, then the remaining part of 3D, what is left out, may be very, very different or difficult for you, right? So don't take it otherwise that sir is explaining much more here, which is unnecessary. You can do it lightly, probably, right? So now I'll not take any different equations of this kind, right? Now I'll take one more question, right? I'll take one vector also in the next, but now number 2, I'll be taking one question where one variable is dropped. That can be a question, right? 3x plus say 2z is equal to minus 5. Y is dropped. No need to worry. Why to worry about, right? So first of all, if that value is dropped, that variable is dropped, it is not necessary that you should write it, but you can reflect it like this. It is but not at all necessary. because without that also you can verify whether they will form the direction cosines or direction ratios. Now it's very clear. Will they form direction ratio? Yeah, their direction ratio, not direction cosine, because 3 square itself is 9. If you add something to it, cannot be 1, right? Okay. So what is the process? We have to divide it by 3 square plus 0 square plus 2 square x. Then 0, if you would like to waste your time, you can divide this also. I don't have anything to say about this, but you may not show this, no problem. And then 2 times this is here, 3 square plus 0 square plus 2 square, and right hand side is minus 5. I emphasize on the minus. Did you notice? Because I have to take this time the negative square root, right? So in that case, what will I get? Here is this. This is 9, 9 plus 4, 13. Then here it will be 0. Then here it is 2 by root over 13 z, and this is 5 by root over 13. So now the dialog already you know is very similar to the previous one. You should write which is in the form of Lx plus My plus Nz equal to 0. D. Therefore, D equal to 5 by root over 13, that is 5 root over 13 divided by 13 units is the required perpendicular distance from the origin. That's it, right? So this way you can do the problems of this kind. Now under the same heading, I would like to consider vector equation. At least one I'll be doing, not more than that. One will be enough for you, right? R dot 2i cap plus j cap minus k cap plus 3 equal to 0. As I told you, the first form we'll always consider as the standard form. That's the first form, right? R dot n vector. I should have written this in the right side, but this is a way also I can write this side. You have to adjust that, right? Now you have to find the perpendicular distance of this plane from the origin. Rethink. Just think, I am transferring 3 to the right side. First thing I did. Next thing you have to decide now, this is belonging to which form? Star or star dash? The equations I am talking about which are marked during the deduction of the first equation. Star was containing n cap, star dash was containing n vector. Now tell me whether this is a unit vector or a general vector having some other magnitudes. How you do it? Find a magnitude, na? So if you find a magnitude 4 plus 1 plus 1, root over 6 will come. That means this is not a unit vector. So your first task is to convert this into a unit vector. How do you convert, or how do you get the unit vector along a vector? Very simple. What you do? Dividing the vector by its magnitude. So both the sides you divide by the magnitude of this vector, right? This vector's magnitude already we have done. It is root over 6. Root over 6, right? 4 plus 1 plus 1, and at a time, see, I have taken a shortcut. 3 I have taken to the right side. Acha. Now there is a problem. We have a minus sign left. How did we tackle that? Very easy. Put a minus sign, right? So now you may not show the simplifications. I leave it to you. So after that, what you'll write, you know? Okay, let's see. We have done only one equation of this kind. Let me complete this. Otherwise, you may face problem in writing the solutions. So this will be, at a time I am simplifying. 6 will be there. Root 6 will go up, right? So 3 will cut 6 by 2. So it's overall root over 6 by 2. So this directly I can write as R dot n cap equal to D, where this is another style you can use. D equal to root 6 by 2 units is the required perpendicular distance from origin, right? So that's it. Okay, so this is one of the problem which is very very important, very basic, right? Depending on the first. Now there is a very I should not say important, but very what I say, very small problems where students commit mistakes. Conversion of one form to the another, right? Vector to Cartesian, Cartesian to vector, because this is needed. You must be very swift, very quick in doing the conversion, because many times we need this. So next question is conversion, right? From one form to another. Let's see how quickly we do it, right? We'll be able to do it, no problem. Question number 2. Convert into vector form, right? First we are converting from Cartesian to vector form. Say, okay, let me take the first equation only, which I have considered. I would like to convert this into vector form in the same step, right? R dot will come, right? That you remember, R n vector या फिर R n cap. Now just try to remember this, everything will remain same except this. Just try to remember the conversion. When the vectors were converted, vector form is converted to the Cartesian form, components of the vectors were becoming the coefficients of x, y, z. Now the reverse process. If I have the general form in Cartesian form, coefficients of x, y, z will become the component of the vector. So 2 will become 2 I cap, 3 j cap, 4 k cap. So that's it. And if you need even a very small memory type of tips to convert this, nothing to be done. R dot you write, and then x, y, z should be replaced by I cap, j cap, k cap, right? I am rewriting the same equation 2 times, right? So if I take another equation quickly, say minus x y plus 2z is equal to say minus 7, right? You do not touch any other part, right? So this will be what? R dot x will be replaced by I cap. So simply y will be j cap, 2 k cap, minus 7. Then if I write another equation, suppose I am giving you equation 3 minus y plus 2z, say plus 5 equal to 0. Your equation will be R dot 3 this plus 5. Did you get this? So this is the way how we proceed for conversion of Cartesian form into vector form. And the reverse is also very clear. Here only I explain you. I will not take separate problem, but I will be giving you assignment on that. If you have the equation, how to write this? Simple here. You drop vector R completely. I cap, j cap, k cap. Make it x, y, z. Right? Write it. So twice x plus 3y plus 4z equal to 5. Equation is obtained. Then this you see, minus x plus y plus 2z is equal to minus 7. Equation is ready. So that's it. You have to do this. Right? So today we have discussed the deduction of 3 planes. Right? I sum up with the important points. First thing, plane doesn't have its own direction ratios or direction cosines. We express the plane's direction ratios with the help of the perpendicular drawn to it. The reason is that anywhere if you draw perpendicular, it remains same, right? And secondly, the coefficient of the variables when you write the plane's equation always represents either the direction ratios or the direction cosine of that perpendicular. That's it. So today I finish with this. We'll take the problems, more problems before we go for the theoretical concepts of the next part. So see you and stay healthy. Bye.